Hey guys, welcome back to the channel Code with AKJ. Today is day 20 of solving Geeks for Geeks problem of the day. Today's question is count ways to nth stair. So the question says there are n stairs and a person standing at the bottom wants to reach the top. The person can climb either one stair or two stairs at a time. Count the number of ways the person can reach the top. Here order does not matter. It means 121, 211 and 112 in this case would be considered as same. So let's understand this question through diagram. So the person standing at the bottom of this ground and he needs to reach at the top of the stair. So he has mainly three possible ways to reach at the top. That would be taking one stair at a time, which would result in this particular solution. And one way would be to take one step at a time, two times, and finally two steps at a time. So that would be one case. And finally taking two steps two times. So it would be 2 and 2. So these would be three cases we need to return. So it's a pretty straightforward classical dynamic programming problem. Here the brute force approach would be to use recursion, and we need to try all possible paths from bottom to the top. So since we are using recursion, there would be a base case, and here the base case would be if we reach at the 0th step, there could be only one way of reaching that particular step. That would, so we return 1. And I have written a recurrence relation where f of I represents the number of ways to reach that particular index I. So from here, if we need to reach at the bottom of the stair, there could be two ways. We'll find the number of ways by taking one step and the number of ways by taking two steps. So and we need to consider that particular step as well. So we'll add that one to it, and finally we'll return 1 plus minimum of ways 1 by taking one step and ways 2 by taking two steps. So this is a pretty straightforward question, and let's code this approach. So this is the code for the brute force approach we have discussed through a diagram. So base case here would be to if we reach at the 0th stair or the first stair, the number of ways to reach that particular stair would be. So as we are using top down approach, we'll start from the top and we'll calculate the recurrence relation from the top. So we'll use two recursive calls. One would be by taking one step back, so n minus 1, and another way would be to take two steps back, would be n minus 2. So finally we'll take the minimum of these two recurrence calls, and finally we'll add 1 to it to include the current step as well. So let's compile and run this. So let's submit. As you can see, this problem gives time limit exceeded as vehicular state is being calculated again and again. So the optimized way of solving this would be to use memoization. So first of all, we need to check how many parameters are being changing after each and every call stack. Since here one argument is being changing, so we'll use singular vector and we'll store that call stack value in that particular vector. So let's code this optimized way of solving this, and let's see if it gets submitted or we need to move to the tabulation method. So this is the memoized code where we have taken a vector of int and we have stored the values initially -1, and whenever a particular call stack is being calculated again, we'll directly check whether it's already calculated or not. If calculated, we'll return that particular value, or else we'll store that value through this step. So let's compile and run this. Let's submit. As you can see, this problem got submitted successfully. So in this way, we have reduced the time complexity, and the way we got time limit exceeded in our recursive approach, we have stored the call stack value in the form of vector of dp. Space complexity here would be often as we are using an extra data structure of vector here. So this is it, guys. I hope you like this video and explanation. So it was pretty straightforward, classical dynamic programming problem. So if you like this video, please give it a like, share with your friends, and subscribe to my channel for more such videos. I'll see you in the next one. Thank you.